Hi students, welcome back to my channel. The topic for today is haloalkanes and haloarenes physical properties. Okay, as you can see, I will discuss physical properties which will include three main points: melting and boiling point, solubility and density. Now, I will also tell you the type of question that is asked from these physical properties. There are two possibilities. First question is that will be asked about arrangement. Okay. Various examples will be given to you and you need to arrange them in ascending order or descending order on the basis of their melting point, boiling point, solubility, density. Okay. The question will ask you to arrange the given names or formulas in either ascending order or descending order on the basis of any of these 3 points, point 1, 2 or 3. And the other type of question that is asked is about give reason. In this, a statement will be given to you and a reason will be asked. So, I am going to discuss all these 3 properties with you so that you will be able to attempt both these types of questions. Okay. Now, first of all, let us see the physical state. Okay. The physical state. They are colorless at room temperature. They means haloalkanes are colorless at room temperature. Bromides and iodides develop color when exposed to light. Okay. Then methyl chloride, methyl bromide, methyl fluoride and ethyl chloride are gases at room temperature. Other alkyl halides up to C18 are colorless liquids and those beyond C18 are colorless solids. All these points are given in NCERT as well. You just need to note down these points. There is nothing as such explanation required. Okay, now see the next one. Boiling points. Okay, very important topic. Boiling points of haloalkanes. First I am discussing. See the first point as it is written. Boiling points of chlorides, bromides and iodides are considerably higher than those of hydrocarbons of comparable molecular masses. In order to understand this point, see, suppose I have CH4. Okay. Now, if I remove one H, then what will happen? And add a halogen, it will become CH3Cl. Now, according to the first point, the boiling point of this chloride will be higher than those of the hydrocarbon of comparable molecular mass. So, if we compare these two, then this one, methyl chloride will have a higher boiling point in comparison to its parent hydrocarbon. Why it is called parent hydrocarbon? Because it is derived from this. So this you need to remember. Now why this is so? See, one main reason is that boiling point is proportional to the boiling point is proportional to the molecular mass or molar mass. You need to remember this. Now, if you see in this case, the molar mass of this compound boiling point is proportional to molar mass. Now in this case the molar mass for this will be higher than this, so the boiling point of methyl chloride will be higher than methane. Okay, now let's move on to our previous slide. See, so the point is clear to you now. The first point, boiling point of chlorides, bromides and iodides are considerably higher than those of hydrocarbons of comparable molecular mass. The reason behind this is that boiling point is proportional to molar mass. Okay. Now see the second point. For the same alkyl group, if we keep R constant, the boiling point of alkyl halides decreases in the order. Okay. For Ri, it will be highest, then Rbr, then Rcl, now Rf. Again, this point can be related to the relation that boiling point is proportional to molar mass. Now, if you see the halogens, first fluorine comes, fluorine, chlorine, bromine and iodine. Okay. Now, as we move down, the molar mass increases. So, if we keep R constant, then the molar mass will be higher for Ri. So, the boiling point will follow the order given. Okay. Now, let's move on to our next point. See, it is written, the reason is written for this series, because with increase in size, the mass of halogen atom increases, the magnitude of van der Waals forces of attraction also increases. As the size will increase, the magnitude of van der Waals forces of attraction between those molecules will also increase, and so the boiling point will also increase. Now let's see our next point. For isomeric alkyl halides, the boiling point decreases with branching. Very important. This will help you in answering the questions in which you have to arrange in increasing and decreasing order. For isomeric alkyl halides, the boiling point decreases with increase in branching. Okay, again it is written the same thing, the boiling point decreases with increase in branching. Now I am discussing this point in detail. See. So according to the last point, you need to remember this relation that boiling point is proportional to 1 upon branching. You can remember this short relationship. Okay, that boiling point is proportional to 1 upon branching. If I compare two examples, suppose if I write N-bromobutane, okay, if I write CH3, CH2, 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 Br, and if I write its isomeric form, which is isobromobutane, okay, if I write this CH3, 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 and Br, and follow this relationship, then it means the boiling point of normal butane will be higher than the other one, isobromobutane. Why this is so? Because this molecule will have a lesser surface area. Okay, as you can see, the surface area for this is more in comparison to this, because it has acquired a spherical shape. So the surface area will be less, and so the van der Waals forces also decreases. Okay, I am repeating. More the surface area, more the molecule will interact, and more will be the van der Waals force of attraction, and more will be the BP. Against this, if the structure is spherical, there will be lesser surface area, and so the van der Waals forces decreases, and it will have a lower boiling point. Okay. I hope it is clear to you now. Now see, I hope these all points are clear to you. In this slide, let's move on to our next slide. Okay, one more thing, one more point I will discuss with you before this. See students, one condition is left. Now see, as I have kept one thing constant in the previous slide, now if we compare examples in which the number of halides is increasing, for example, if I compare CH3Cl with CH2Cl2, and if I have CHCl3 and if I have CCl4. Okay. Now if I need to arrange this in accordance to increasing boiling point, then the series will be this way. Because with the increase in number of halogens, boiling point will increase because the molecular mass increases. With the increase in number of halogen, there will be increase in molecular mass, so the boiling point will also increase. So this is another series that you need to remember. Okay. Now let's move on to our next slide. Here I am talking about haloarenes. The decreasing order of boiling point is iodoarenes, bromoarenes, chloroarenes, fluoroarenes. I hope you might have understood this because this point I have discussed in haloalkenes. Then see, for the same halogen atom, the boiling point increases with increase in molecular mass. This is again related to the last point I have discussed right now. And for isomeric dihaloarenes, boiling point are roughly identical. Okay, this is seen for isomeric dihaloarenes. The boiling points are roughly identical. This example is given in your NCERT book as well. I am discussing the same example of dichloroarenes. See students, this example is given in your NCERT book. Suppose now I am discussing ClCl. This is which isomer? Ortho. And if I write this way, this is meta. And if I write this way, this will be para. Now the values of boiling point given in NCERT book are 453, 446 and 448. So as you can see, the values are almost similar. Okay, boiling point values. This was the last point of the previous slide. Now very important property I am going to discuss, that is melting point. Many times question is asked from here. I am discussing melting point of haloarene. See the first point, melting point of haloarene are roughly the same as those of haloalkanes with identical number of carbon atoms. Okay. Now the melting point of isomeric dihalobenzenes are of the order para, ortho and meta. The melting point for para isomer is the highest. This is the question that is asked in exam. Why is the melting point of para isomer the highest? The higher melting point of para derivative is due to its symmetry, which leads to a better fitting of its molecule in crystal lattice. This is the reason that you have to write down. Okay. See, I am discussing this point again. Here see, I have mentioned the boiling points of these three, ortho, meta and para. Now I am discussing the melting points. First of all, I will write down the value that is given in your NCERT. See students, the values given here is 256, 249 and 323. These are the values for melting point, okay, as per NCERT. Now if you compare, you will see the para isomer has the highest melting point. Why this is so? Because if you see the para isomer, it has a plane of symmetry. So its crystal lattice has close packing and symmetrical structure, so it will have a higher melting point. Okay, since it has a plane of symmetry, so it will have a better packing or close packing, and that is why it will have a higher melting point. Note this point carefully because it is asked many times in your exam. Okay. Now let's move on to our next point. Solubility. Now I am going to discuss with you solubility. Okay. Now see the first point. Haloalkanes are only slightly soluble in water. Haloalkanes are only slightly soluble in water. Now why this is so? The question comes why? I am going to discuss with you this in detail. The reason is given in your NCERT that I will tell you later. First let me explain the point. Now suppose we are going to discuss solubility, and we have seen the point the haloalkanes are only very slightly soluble in water. Suppose I have two containers. Now if in the first container I have any of the haloalkane, suppose I have RCl, many molecules of RCl, this is first molecule, this is second molecule. Now in this container if I have water, H2O, one molecule, and H2O, other molecule. Now you know that between water molecules there is what? Hydrogen bonding is present. And if you see this RCl, then you must know that RCl is a polar molecule. Why? Because the electronegativity of Cl is more than R, so it will develop a slightly negative charge, delta minus, and it will develop slightly positive charge. It means it is a polar molecule. Now the type of interaction between two molecules will be dipole-dipole. Okay, it will be dipole-dipole interaction. Okay. Now see, I hope this is clear to you. That in this beaker or this container I have RCl, and the type of interaction between RCl molecules is dipole-dipole, and between water molecules it is hydrogen bonding. Now if I mix these two, then what will have to be happened? That the attraction forces between the same molecules will break up, then only new attraction forces will develop between RCl and H2O. It will mix only when new attraction forces are developed. Now, first of all, what will happen? These hydrogen bonds or these dipole-dipole interaction should break. Okay. Now, you know that in order to break a bond, we need to supply energy. Supply some energy, supply energy. And in order to develop new bonds, new forces of attraction, we need to provide energy. Okay, now energy required to break the bond between alkyl halide and water is more than the energy released during bond formation of alkyl halide and water, so it is insoluble in water. So if we compare these two energies, okay, now I am reading the statement given in your NCERT that in order to form haloalkane to dissolve in water, energy is required to overcome the attractions between haloalkane molecules and break the hydrogen bonds between water molecules. I have told you. Now less energy is released when new attractions are set up between the haloalkane and water molecule, as these are not as strong as original hydrogen bonds in the water. As a result, the solubility of haloalkanes in water is low. Okay. So, new bond will be developed only when heat energy evolved is less as compared to breaking of existing bond. I hope this is clear to you. See, again I am telling you the reason that you have to write in this. That energy required to break the bond between alkyl halide and water. Energy required. Sorry, it should be required. I think I have said opposite. Energy required to break the bond. Which bonds? Which are already there, these and these bond, is more than the energy released during the bond formation. Okay. And when bonds will be formed, new bonds will be formed, the energy released during new bond formation. So, these alkyl halides are insoluble in water. Okay. So, this was the explanation of this first point. Now, see the second point. Haloalkanes tend to dissolve in organic solvents. Okay, this you need to remember that haloalkanes are insoluble in water, but they are soluble in organic solvents. Because in this case, the new intermolecular attractions between haloalkanes and solvent molecules have much the same strength as the ones being broken in separate haloalkane and solvent molecules. Here both the energy magnitude will be same. So these are soluble in organic solvents. Now let us discuss our last property, which is density. Okay. Now see what is written. Alkyl chlorides and fluorides have density lower than water. Second point, alkyl bromides and iodides are heavier than water. So the relative order on the basis of these 2 points, the order is this: Ri, then Rbr, then RCl. This order of density you need to remember. Reason, as the atomic mass decreases, density decreases. See, as the atomic mass decreases, density decreases. Or you know the formula that density is equal to, yes, mass upon volume. Now, if you see this relation, you can understand that density increases with increase in molar mass. As the molar mass increases, density also increases. So, we can make the following series. RCl, then water as it was given in the statements, RBr and Ri. In fact, you should write this series. Okay. So, this will be lighter and this will be heavier in terms of density. Okay. So, this was about density. So here we come to the end of the topic, in which we have discussed about melting point and boiling point, solubility and density. Okay, students, that's all for today. Thank you.